Hello and welcome to the CTS-1134 review. This is for the fall semester of 2022 and for the introduction to networking technologies. This is not a chapter by chapter review, but in turn is more of a overall review of topics that you should know as a Network Plus. If you go to a workplace requiring Network Plus experience, these are some of the things that I would expect from someone that is in networking. The first and most important is the OSI model. The OSI model is the basis of networking. These are the protocols, the rules, or the things that you should know because Ethernet, TCP/IP, and all these protocols obey these rules. So if you need to troubleshoot any kind of communication, this is what you want to know. So let's start by the top. So the layer 7 is my application layer, right? This is where my payload starts. My payload is my data that I'm going to be sending or replying to any other system. So the top three layers are software layers. This is something that happens at the computer in the application by itself. So the presentation layer is there, which works out on how the things are going to be set up, and it also the session layer is there, which session layer is the one that establishes the session, does some of the encryption and some of the tear down, and all that happens at that and this layer. Then so that was layer 7, layer 6, and layer 5. That's your software layers. Then you have your transport layer, your layer 4. At the layer 4, this is the heart of the OSI, right? This is where things separate now from the machine, the routing, and the application. At this level, you expect to see your TCP and UDP ports, right? All your ports are at layer 4. And here, the payload, it's encapsulated on what's called a segment. So every time we talk about segments, it's layer 4 pieces of data. Then layer 4 gets encapsulated down into a layer 3, which is the network layer. Here's where your routers operate. Your routers are on this layer. And at this layer, then the IP addresses are added. This is for your source, your destination. Anything that happens at layer 3 is here. All your routing, like I said, needs to know IP addresses. That's the only way you can route a source or destination. And this encapsulated packet is called a packet. So once it goes, the segment gets encapsulated inside this encapsulation, and is called a packet. Then the packets go into the layer 2, your data link layer, right? This is where all your switches operate. At the switch level, what they know it's MAC addresses. So your MAC addresses are layer 2 indicators. This is where you have frames. So you might see a lot of errors or reports where it says frame errors or anything or fragmentations. Then it happens right on your frames on the layer 2. And then you have your layer 1, your physical layer. Your physical layer is the wire or wireless, either way, or if it's fiber optics, it's the fiber. And this is where all your ones and zeros go, right? So the first three layers are your hardware layers. Everything happens here with your wire, a layer 1, with your switches a layer 2, and the routers a layer 3. So when I'm sending any information, my payload has to be brought down through all these layers. It goes into the back of the computer on the network card. The network card, it knows the network layer to have the IP address for that connection that you have. The network card also has a MAC address identifier that reports to the switch, and it goes through there to the physical layer to transfer to the switch. The switch in turn will open it up to the layer 2, inspect that, and see what it needs to do with that frame. If it needs to forward to the router, then it will forward to the router to do layer 3 routing or the distribution of this information. Now, starting with the layer 1, this is where your cabling are, right? The EIA-TIA standard defines the order of the cabling for the T568A and T568B. The most common one that you will see in the industry is the 568B. There are some places like hospitals or some industries that they will require the 568A. I think government will require that, and some of the hospitals. So you will have the four pairs of cables, right? You got your green pair, your orange pair, your blue pair, and your brown pair. The order of the cable depends if it's a 568A or 568B. And you have to remember this because this is a standard. And if you see, the blue is always in the same place, it doesn't change. The brown is always at the end, it doesn't change. The ones that actually change positions in this schema here is that 568B will have orange on the first pair, and then green is a split between pin 3 and 6. It's reversed on 568A, which has green first, and then orange is the one that is a split between the 3 and 6. Okay, there are different kinds of cables. You know, the Cat5e, Cat5.6. Cat5e is what you need to communicate at 1 gig, right? For 1 gig, you require all 4 pairs. The 100 megs uses only 2 pairs. Only you need the orange and green pairs to communicate is only up to 100 megs, and that's Cat5 cable, right? If you want anything faster than that, you need to go Cat5e or higher, you know, Cat5e or Cat5.6 better. That will provide you a 1 gig connection. And like I said, please remember that for 1 gig connections, you need all 4 pairs. If you have 1 pair missing, it will not run at 1 gig and will drop to 100 megs or even less. If you're running cables above the ceiling, that's where you have to use platinum rated cable. Platinum rated cable means that if there is a fire, the sheeting that holds the coating of the wire is a fire retardant. It doesn't produce any fumes that are toxic. So it is actually made specifically for running above the ceiling. Okay. Also on this Cat5 or Cat5e or Cat6, you'll see that it carries PoE on either connections for 100 megs or even 1 gig or even 10 gigs. PoE is carried over the same cables. The 1 gig connections now are very sophisticated in the way that they send power through all the pairs. And that will provide PoE or power over Ethernet to phones, cameras, and other devices. So where do you do all this cabling? The MDF or IDF, the main distribution frame or your intermediate distribution frames. The MDF is the entry point where all your ISP services are, and that's where all the your DMARC is. That's the DMARC is when the point where your provider leaves their connection. So on the MDF is the main distribution frame. It's only one per site because it's the one entry point. And from there you have a cable is going through all the different areas. Remember that if you're in one floor, you run what's called the horizontal wiring, which is going from your IDF across the ceiling down to the workstation. If you're going across floors, which most likely is going to be fiber, that's your vertical wiring. Vertical because it goes vertically between floors. Sometimes vertical wiring is also going between building to building because that's how you connect everything together. But that vertical wiring will connect all the IDFs together. Most likely there's multiple pairs of fibers. There's some of them terminate on the second floor, some of them terminate on the third floor. And that's where you will see your connections, right? Remember that for your horizontal wiring, you cannot extend more than 100 meters. That is not allowed. It actually, for any type of cabling, it will just the connection would fail, right? You should avoid any EMI noise. Run the cables close to fluorescent lights. I think it's about 3 or 4 feet away from them, and also from any motors. Any place that has a microwave oven. Microwave ovens generates a lot of interference, so you want to have the cabling away from those rooms. The fiber cables will provide a faster uplinks, right? And also they're immune to noise and to any interference. So this is perfect for to go from building to building or from floor to floor. They could be single mode or multi-mode. Fiber can be in either way. A single mode for long hauls and multi-mode for short hauls. So then you have to use the corresponding modules for this, which will be either short haul or long haul for the 1 gig, or on the 10 gigs actually called short reach or long reach, or the ERs, which are the extended reach. Right now, remember that fiber optic is a more expensive solution. Right? It's not cheap. It is expensive. So it is faster. It is better. It has a noise, cannot be affected by noise or any EMI or anything like that, but it is expensive. So when you cost your budget, you have to see, what will be the cost to add this fiber to it, because it is expensive. So once everything is connected and you connect your computers to the network, what do you need? Well, your computer will go for the DHCP, right? The DHCP is the one that provides dynamic host control protocol, is the one that provides IP information to the clients. It will provide you with an IP address, a subnet mask, and your gateway, so you know who's your gateway for your connection. That will determine also which network you're connected on. It will provide you with the DNS IP addresses. It will provide you with NTP. Remember, NTP is the network time protocol that provides timing. And DNS is the dynamic name service that provides the fully qualified domain translation to IP addresses, right? The internet cannot work on names, so the computer needs to know what's the IP address. So the first thing it will do is it will go to this IP address that was assigned on DNS and says, hey, you're my assigned DNS, and I need to request a translation to an IP address. When you go there, the computer would actually go to your local DNS server. It will go to the second level domains to find where your IP that you're looking for. So obviously, if I'm going to google.com, I cannot query the mdc.edu. So it will go to the top level domains and say, hey, okay, where is the google.com? And then the top level domain will route you to the root level, and the root will send you to the .coms, and then you'll find your AT&T.com and provide the DNS resolution for any services within AT&T, right? So the fully qualified domain names are actually built with in a format separated by periods, where you get your host dot, your subdomain dot, second level domain dot, top level domain. So the kenobi.it.mdc.edu means that it's within Miami-Dade, there's a subdomain for IT, and the machine host is Kenobi. Right. There are multiple DNS records that you can get on DNS. It's not only the translation. The one that provides the translation are the A records. A records will provide you the IP for IP addresses for any FQDNs. If it is for an IPv6, it uses what's called a quad A record. That's the one that translates the fully qualified domain name to a IPv6 IP address. You also can get queries for CNAME. CNAME is an alias. It's a canonical name that will provide, it's just like an alias. I can have, payroll.mdc.edu that is an alias for ACCT01, for accounting01.mdc.edu, which is the actual server. But to make it easier, I can do a CNAME, an alias, as for payroll.mdc.edu. You can also have MX Records. MX Records is the one that provides the mail exchange, who is the email server for this domain. You can also have text records. Text records are usually for reference, that you can go and get reference to make sure that to authorize certain services. And also you can have records for CAA, for the Certificate Authority Authentication. Just so some domains can be authenticated, right? And just as a note, remember that the most popular DNS is BIND. That BIND was Berkeley Internet Name Domain. It was written a long time ago in the 80s, and by 9 it's a new version that was replaced in the year 2000. But you'll be surprised how many systems that do DNS uses bind in the background as the bind from the 80s. It hasn't changed anything. You know. Oh, I forgot to mention here that also the DHCP will provide you voice VLAN ID and voice gateway information. So the if you have a phone connected, DHCP will provide information to the phones. Also, this is some of the Windows command tools that you should learn, something you should get used to working with. We have worked a lot with pings, right? Pings is the one that sends ICMP packets to another endpoint, and that's how you can find delay in the systems or see if the system is available. ipconfig, we also tried that before, is the one that shows your current IP configuration for the client. So this is on a Windows command prompt. If you do ipconfig /all, that's when it shows all the information for your DNSs and your WINS setup and all that. NSLOOKUP is a great tool. It's a manual DNS query to your DNS server. And you can, if you think that there's any problems with DNS, you can just open NSLOOKUP on your computer. You just type NSLOOKUP and then query any name just to see if it replies. Also, when you open it, you will see that it will tell you which server is using to request the DNS query. So you can actually type server space and another IP address of another server that you know, so you can actually query a different server just to do some testing. TraceRT or traceroute. It's an utility that shows all your path across multiple networks. So it will show your path between one location to another IP address. If I do a trace route to 4.2.2.2, it will show all the way from your computer as it routes out of your network to your provider, through the provider, all the way to that. So it is also a good troubleshooting tool to see if you actually make it there or if it gets delayed somewhere along the line. Sometimes when traffic is slow, you can do a trace route and see somewhere along the line where things are getting slow. ARP is another good utility. It shows your TCP connections being made for the client and others. This is also provides your IP to MAC translation to other endpoints, right? Especially on a router, you can do a router, since it's a layer 3 device, you can do a show ARP, and it will show you the matching IP addresses with the MAC addresses that the router knows about. So, and you can trust those because that's how the router is using to communicate with all the equipment. So it is on the router and also your computer. NetStat is another utility that displays all your TCP connections and components on your computer, whatever is active. This is good to know in case that you're suspect of viruses or anything like that, or just to see if you're actually making a connection to a server or any endpoint. If there's any communication there, NetStat will show all those TCP IP connections. You can get TCP dump on Windows, but it's native on Linux, on Mac OS. TCP dump is just another packet analyzer, right? And it runs on a command line. Unlike Wireshark, the Wireshark runs on Windows with a nice graphical interface, and you click, 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 and see all these colors and all that. TCP dump is on a command line, so it's just text. And you can do filtering, you can do everything, but everything has to be done at the command line. But it is a great utility. Like I said, it is available for Windows, but is native on Linux and Mac OS. If you're on the Mac OS world, you don't do ipconfig, you do ifconfig. And for traceroute, you actually do the whole word, not like in Windows that you shorten to traceRT. Now we're coming to the TCP header. Remember, the TCP header is the one that has all the information that your router, your switches, and everything in your computer needs in order to communicate to a destination. So you will see, like on this, it described the source port and the destination port, right? And also you see your sequence numbers, and there's also the acknowledgements are here, and these are all the flags that you can have on the computer. So you can have your FIN, you can have your SYN for synchronize. This is to reset the connection, right? A push is here. So all of these are fields, acknowledgements that are either 0 or 1. So it's just a 1 bit that it gets set either to 0 or to 1. Either you have an acknowledgement or you don't have an acknowledgement. And one important thing also here is your window size. Remember that on Windows, in Ethernet, you have the window size. that actually determines how big of a packet you're going to be sending. That's a handshake that you do with your client to see how much information you can send on one thing. And going into this, remember the three-way handshake. This is something important to remember because even I have got one of those questions in a recent interview that I had, and they asked me, "Do you know the three-way handshake?" I was like, "Of course, it's simple." Source A, destination B will start communications. So source A will send a SYN to say, "Hey, I want to talk to you," and then of course B has to be listening for that SYN, and it will reply back with a SYN ACT. So I'm asking for a synchronization, and I get a synchronization plus acknowledgement that he received it. So now I acknowledge back to say, okay, I did receive your acknowledgement, so now I establish a communication. This is what's called the three-way communication. The three-way handshake. That's the handshake that happens there. So once you have the handshake, now I can say, hey, I'm going to send you ABC. And he goes, okay, I acknowledge that. Okay, I'm going to send you the EEF. All right, I received that, so I acknowledge that I received that. And then I'm going to send FUBAR, which it said, yeah, I received it. And I received they send me a hello, and I send a goodbye that I'm going to be disconnecting. But that goodbye is just text that I'm sending, right? So to close the connection is similar to the three-way handshake. I need to send a FIN to finalize. They get an acknowledgement that they did receive my FIN, and then they send me their FIN to finalize, to close the connection, say close and wait. And then I reply back, said, okay, I'm accepting your FIN too, and the connection is closed. So if we go another higher layer, and we get into the layer 3, that's where routing happens. And routing is what decides which way traffic is going to go, which path, in order to get to my destination. So all these routers that you traverse through in the middle should have this shared protocol, right? So you can redistribute routes and inject the routes. So when I have 3 routers like this, and I want to send traffic from router 1 to router 3 on the other side, then the router in the middle needs to have to be talking the same protocol all across, so they can share that routing information, right? So this in the SDN, the software-defined networks, this is what is called also the data plane or the infrastructure plane. This is what carries the network and decides what to do with the package when it arrives on an interface. So the infrastructure plane is what decides, okay, well, I get a packet, which is the best way to get it from point A to point B. Now there's 2 ways to do it. You can do it through static routes, where you manually enter the routes and they will not change. In the past it was always one way. In this case, we only have 3 routers, so yes, in order to go from router 1 to router 3 on the right, I have to go to a router in the middle, so there's no other way. But when there's more routers in place, then you have to decide which is the best way to get there. And for that, you'll use some dynamic routing. Dynamic routing calculates the route based on the member's path. We went over how OSPF works and how they share their information, or how they start discovering what the other ones know, and how to get from every point from where you are standing. So some of the basic routing protocols is OSPF is one of the most widely used. The second best is ISIS. It's a faster, better protocol, but it's a little bit not so understood by IT people, so they prefer OSPF. ATM it's like an obsolete protocol, but it's still in use in some places. Then you have BGP, but BGP is more like external. Remember that the internet runs on BGP. The Border Gateway Protocol is the one that is using the internet. So once you leave your enterprise and go out to the internet to your provider, you have to run BGP. You can also have internal BGP, iBGP, but that's in case you have multiple sites and you want to run BGP between them, which is perfectly fine as long as you run it on your edge routers. Okay, now there's a few measurements here, what's called a convergence time. That's the time that it takes to exchange information. They're constantly exchanging information. So any modification, any changes, anything that got removed or added, it gets propagated into the network. That is called the convergence time, right? And they will add that information to your routing table. Okay, so and then every time there's a change, the path is defined with a new matrix to see how I can get from point A to point B if my path has changed and if I found a better way to get there. All of this, layer 3, happens at the routers. I said, remember that switches do not do routing. They do layer 2, which do not know how to deal with IP addresses, and only routers can do that. So if you have switches in the middle, these switches can only switch traffic between one workstation to another, between them. But when they need to go to another network, then you have to forward that to the router, so the router can actually make that connection to other routers to get to other networks in your enterprise. So this is another view of your routing. So if you have an enterprise meaning having a large network, right? So you're going to have internal routers. Those internal routers, they connect sites to each other, right? They connect between each other. All those sites will connect to each other through these are internal routers through whatever routing protocol you're running. In the middle, with your IGP, Internet Gateway Protocol, and in this case, we might be using OSPF, right? So internal routers are the one that connect to all your sites and route the traffic inside your enterprise. Then you need to have an edge router. That's the one that connects you to your wide area network and to an ISP. So this is my edge router. It's the one that sits on the edge, and it's the one that connects to my ISP provider, right? And that's the one. What do I run in there? BGP. That's the routing protocol that we'll have to use to connect out to the internet. If you're running OSPF to a provider, then you're not actually fully routing out to the internet. You're being part of that provider, and they're the ones that are doing the routing outside to you. You're not doing it. You need to have BGP in order to do routing directly to the internet. Remember that your wide area network is when the traffic traverses from multiple routers to reach a destination. That's when you travel distances efficiently, and you can get through multiple routers until you get to your destination, wherever you want to go. Okay. Now, there's some IPs that you do not route on the internet that are not allowed on the internet. Some reserved ranges are not allowed on the internet. One of them is the 10.0.0.0/8. So everything that starts with a 10 is a private range. You can use it inside your business. You can use it inside your home. You can use it inside a lab, but not out to the internet. The same thing with 172.16.0.0/12 is a private IP range. We use that at the college for some connections that we have internally for a router. The most popular one also is the 192.168.0.0/16. It's another private IP range. This one means that anything that starts with 192.168, it's not allowed on the internet, but you can use it internally. I mean, this is a Class B address. This Class B address has 65,000 IP address, 255/24 subnets. Right, so there's a lot you can do on a network if you're trying to use IP addresses on the private. Another IP address that's not allowed on the internet, it's the link local. This is the 169.254.0.0/16, meaning that anything that you see that starts with 169.254 is not allowed on the internet. This is what's called Windows call it the API-PA. But it's a link local address. Even Linux and Mac OS will use that IP address in case that you don't have a DHCP. So this is a self-assigned IP address. I said, hey, if I self-assigned IP address within a 65,000 range, there's chances are that I will not have a duplicate IP within a sizable good network, right? So you can use that as a last resource. The 127.0.0, and I'm missing a 0 there. That 8 is the loopback addresses. The loopback addresses are self-addressed on the system to loop back to themselves. So those are not allowed on the internet. IP multicast is to when you want to send traffic is to multiple systems at the same time. So anything that starts with 224 is also prohibit from going to the internet. And of course, the 255.25.25.25, which is /32, like that, that's the all ones. It's a limited broadcast that cannot go out to the internet. So just be aware that whenever you go out in the routing world, then actually you might want to block these things for coming into your network, just in case somebody will inject something, because they will inject it, and you want to make sure that at least all these ranges actually block from getting into your network. Now the last slide on routing, I promise. Well, Cisco defines 3 layers on the network. The core layer, that this is usually where all the backbone is, all your routing happens there, right? And this is where you have connected through high-speed cables and like fiber and things like that. You have your distribution layer, which is this is the one that ensures that packets are sent to the right subnets and the right VLANs, right? That's your distribution layer. And then you have your access layer, which the access layer is where all your switches reside, right? That's where you connect to your desktop. So you got your core where all your routing happens. Then you got a distribution layer, which is more like a layer 3, layer 2 transition. And then from there, you got your access layer, which are all your switches that connects out to your host. Remember that in this connection here, between your distribution layer and your access layer, all these connections could be they could use trunking. The VLAN trunking is the one that allows you to carry multiple VLANs over the same point-to-point connection. So you don't need to have 4 switches if you have 4 different networks. You can do VLAN trunking, where you can have all your trunks into one port, and that port goes to one switch, and then the switch, a managed switch, of course, the managed switch, you can configure the ports on different VLANs for whatever need you have. Some of the common VLANs that we'll see there is your native VLAN. Native VLAN is the one that carries the untagged traffic, something that it doesn't support tagging. Remember the 802.1q tagging, then it will carry on the native VLAN. You may have a data VLAN. The data is just for your traffic, your general data communication for browsing, emails, a database, anything else, it goes through there. You may have also a voice VLAN for voice-only traffic, and also a management VLAN that's to isolate the management traffic for the switches or any other devices that requires management that doesn't have to be routed or connect to any other part of the network. Because remember, you can use VLAN to isolate traffic. So, on a trunk port, you might see all these 4 as a default: your native VLAN, your data VLAN, your voice, and your management VLANs. But all those are trunk. A trunk is, remember, it's a way to bundle the lines together. Each one gets identified with a header, 802.1q header. When it goes to the switch knows how to interpret that header and deliver that to those ports that have the same VLAN number. Now, if there's a native VLAN, the native VLAN does not have a tag for 802.1q. That's completely untagged traffic. Now, another term that you should be familiar with is multiplexing. Remember, multiplexing is a way to get multiple lines that they're going to be multiplexed or muxed into one single line, and can be carried over from one side to another or over large distances. And then at the other end, they will get demuxed into the original connection. So if you have 4 colors coming in, you got 4 colors coming out. So 4 different networks coming in, 4 different networks coming out. It's a way to put multiple signals. You can actually oversubscribe a line by doing that, because now you have multiple signals going in there. So they're all going at the same time, right? There are ways to prioritize the traffic there, but it also depends on which technology you're using, right? So on the other end, you just demultiplex it or demux it, and that's how you get your signals back from the original form. So why you use multiplexing? Well, because if you want to talk to multiple networks on the other end, without having to dedicate one connection to every single one of them. So rather than having 4 connections, I can have all 4 muxed together and then demux on the other end, right? And If it's something that is expensive connection, then you can maximize the use by doing that. So there's two types of muxing that you can do here. So there's two types of multiplexers. So you have analog or digital. Even analog, of course, analogs are signals that fluctuate over time. So you can have FDM, so frequency division multiplexing. That's when you actually multiplexing frequency. Or in fiber optics, they use wavelengths. You use wavelength division multiplexing, or WDM. That's when you mix multiple wavelengths into one carrier, carry to the other side, and then you demux it to all the different wavelengths. Remember, wavelengths is more like a color of the light. If it's digital, these are all ones and zeros, so here's a little bit more difficult. So you can have a time division multiplexing, because now this is always a ones and zeros there. So use time division multiplexing. We can be in two types, either synchronous TDM or asynchronous TDM. Synchronous TDM is that it uses the same timing for in and out. And the asynchronous is just it varies when you send large packets and receive small ones, and whichever way. So it's actually asynchronous. Wireless is another wire area in IT. You can dedicate yourself only on Wi-Fi and do very well just by doing that. The FCC allocates the range from 9 kilohertz to 300 gigahertz for wireless communication, but the Wi-Fi uses mainly the 2.4 and the 5 gigahertz. Now the Wi-Fi 6. The Wi-Fi 6 is the one that extended, and it runs up to 6 gigahertz spectrum. So nowadays everything is 2.4 or 5 gigahertz, but with the introduction of Wi-Fi 6, which is already running out there, it uses the 5 gigahertz spectrum, so it goes a little bit higher, right? Wi-Fi uses the SSID to identify any network. So there's two types of messages you will see there. You got a BSS SSID that it's sent to the AP and sys clients. That's the infrastructure. So you're part of a BSS when you have multiple clients going to the same access point. And then you have that's the basic service set. And the extended service set is the ESS, which is a group of BSSs that allows roaming. That's when you have the ESS is what runs between multiple access points, so they can communicate with each other and help that roaming. So when you move from one room to another or go into a hallway, then your communications hand off to another access point. So the access points themselves, they need to talk to each other, and they talk to each other through ESS, whereas the access point to its clients will connect through a BSS, which is a basic service set. If you're running ad hoc is just a connection where the clients connect together. Now, on wireless, one of the things you have to be careful is on the antenna radiation patterns, right? That's what defines how the signal is going to propagate, and it depends on the design of the antenna. So you have to be careful with that. So what you do for reliability is that you can do a size survey. And the size survey, you can determine where to place your access points in a more efficient way to provide connections or full coverage for your clients. So the size survey is just for reliability and placement of those access points to provide a better service. Now, when the signal propagates through the air, it gets all kinds of interference. So let me clarify it here. The three important ones that you need to remember and to take into account when you're designing any wireless network. The first thing is reflection. Reflection is a change of direction, right? When the bounce off a barrier. So this is like hitting a mirror, right? It's a reflection. So it goes in, and it depends on the incident angle of where you come into that object. That's the angle that is going to come out. So it depends, it's all the laws of physics, but that's what reflection is, right? Now, refraction is when you change from one medium to another, right? In wireless, it's actually when you're going through walls and you go through those either sheetrock walls or concrete walls or even glass, there's a refraction that happens there. Remember the example when you put a pencil on a glass of water, right? And how it gets refracted because it thinks like if it's broken, because when it goes from one medium to another, that propagation changes. So the same thing happens with the wireless. And the last one is diffraction. Now, diffraction is also a change in direction or split in all the secondary waves when it passes through an open or around barriers. So this is when the signals actually bounce off and go around areas, or when it has to go through small openings, and that opening creates so much bouncing inside that it changes the direction, or it might actually cause the signal to split into multiple subwaves to propagate. So that is diffraction. Now, the 802.11 frame for wireless is a little bit different from the typical TCP/IP header, right? Remember that the wireless LANs, they work at the same as a layer 1 with radio waves, and layer 2 in your data frames. On your layer 3, the header holds 4 IP addresses. The first one is the send IP address, or the laptop where you're connected from, the transmitter on your network card, the receiver on the access point, and also the destination of the IP where you're going to send it to. So this in the middle is what you don't have on the TCP/IP, which is your transmitter and receiver radio information. Now, by the standards of the IEEE, 802.11 standards, 802.11g, it was one of the early ones that worked at 54 megs, and that uses a 2.4 gigahertz, or 802.11a at it will run at 5 gigahertz. Also 54 megs. So the throughput, right? Remember, throughput is the amount of traffic that you can get through your connection, right? That's the maximum throughput. The bandwidth was the amount that you can actually push, but throughput is when you really can get through it. So you can have a bandwidth of 4 lanes, but when the lanes are all full, then your throughput is a lot slower because you cannot get everything to go through. So 802.11n, right, is another standard that runs on 2.4 or 5 gigahertz, and it can give you up to 600 megs. 802.11ac works only at 5 gigahertz, and that's supposed to give you up to 1.3 gigabits per second. Now, the newest standard that runs at 6 gigahertz, it runs at 2.4, 5, or 6 gigahertz, but this is the new Wi-Fi 6, is the 802.11ax. And the AX can provide you up to 9.6 gigabits of throughput on the wireless. So, but this is with the introduction of the 6 gigahertz for the AX that provides you better connection. Now, if you go back to the small connections for Bluetooth and Zigbee, those that use a very small range between 2.4 and 2.4A5. I think Bluetooth limit is 2.4A3. But it can go out to 2.485 gigahertz. And this is the 802.15.1 standard, but that's for like short distance communication, right? And one thing to note, wireless is a half duplex like transmission. It doesn't, unless you have multiple in, multiple out technology, it will behave more like a half duplex, so you have to send before you can receive something. Now, virtualization is another subject that you should be aware of. Of course, this is just it's a platform to run virtual machines, right? Each machine it will run on a host. The host is the one that runs that the virtual machine monitor, which is the one that controls your hypervisor in this case, that will control all your communication and allocation of services to your guests. So you can actually from the original host, you can allocate whatever service and whatever allocations for hard drive, memory, and CPU that your guest requires, right? So all that CPU, memory, network storage, and all that, it's can be allocated for from your virtual machine monitor, or what's called also the hypervisor. Now, all this virtualization also has a virtual NIC, a virtual network interface that connects to a virtual switch. everything is virtual, right? It's virtualized, but it mimics exactly the real world, physical switches and network cards. So there are three ways that you can run this. You can run it on a bridge mode. Bridge mode means that your connection is actually bridged, and you can reach the host network. So your main network can be reached directly through the virtual switch. If you NAT it in network address translation, that means that you're going to be hiding behind a single IP address from your host, and your VMs can have any set of IP addresses that they're not seen from the outside because you're NATed from a single IP address. Or you can have the host only mode, which means that you're just going to have hosts inside communicate with each other, and it will never communicate to the outside world. If you need to communicate to the outside world, either you have to be NATed, you can have a 10.something IP address on the inside and add it to the outside, or bridge. On bridge mode, you can actually get DHCP and any other services that are available on your host network, on the real network, directly to every client. So that's when you bridge the network. Okay. And remember, the cloud computer offers all those services, but the host machine is actually someone else's hardware. It's just you're borrowing or renting a space on somebody's hardware. So you can have the infrastructure as a service, the platform as a service, the software as a service, or everything as a service. Don't have to be familiar with all these terms, but just to be familiar with what virtualization is and how virtualization works. Now, through the pandemic, we all learned very well how to work with remote access, right? How to get things from another location, and sometimes unsecure locations that you want to go to a site. So Telnet is one of the old protocols, right? Telnet uses TCP/23. It's text-based. It's very insecure, and it's not safe to not even to use inside your network. So what you should use is SSH, which uses TCP/22, that offers a secure shell that does encryption. So your traffic is not. It cannot be decrypted or seen by anybody else. Some of the protocols which actually run also encrypted, it's RDP or VNC, that they use TCP/3389. That's for remote control of some systems, and mostly Windows uses RDP. Linux will use VNC. That it will make you be like just in front of the machine. It's just like that. Some systems will also have remote access for a URL. So that's when you have an HTTPS a web page that uses, remember, TCP port 443. That is encrypted access, right? And usually when you have an URL, is just to manage and control some applications, some softwares or something that can be used through HTTPS. Another way to remote access is the OOB, a out-of-band access. Is out of band. This is a separate interface to manage and control devices, either a switch or servers and things like that. So that's within your environment that you can do all of this. You tell them that SSH, RDP, URL, or out of band. If you're on a remote site, you might want to do a VPN. The VPN is an encrypted tunnel, right, to access a foreign network from a remote location, kind of like we did with the remote work. So all protocols can safely be used by VPN to create a tunnel. Remember, this will create a tunnel between your workstation and the service. It can go through the public internet, but then it will encrypt everything from your local network to the your work's enterprise network, right? There are different protocols used for VPN. PPTP, L2TP are older and weak protocols. Point-to-point protocols, or the layer 2 protocol is also weak. So what you want to use is either IPv2 or SSL/TLS, which are newer, more robust and more secure connections. Normally on a VPN, you'll need a VPN gateway. So that's for the client server model. So or to create a point-to-point VPN, you can have client to the server, and at the server side you'll have that VPN gateway, or a point-to-point where you can have two business locations where they can connect to each other through a VPN, and all the transactions they do is all protected from anybody tapping into your network. Now, the IP subnetting, VLANs, and VLSM, the variable length subnet masking, is something that I encourage you to go back and re-study that and try to learn more. That's the way that you can allocate your on IPv4, let's say, the portion for your network and your portion for your host. Sometimes also you can have your network and allocate one little space for your subnet and another space for your host, and that way you can subnet your network. This is something that it will take a lot to practice and go more into the binary to get. Remember when you subnet mask, we did an assignment with that, but I encourage you to just go and do your homework on this. Remember, the IP addresses is a factor of 2 because it's binary, right? So practice your binary, and then so you can group IPs in groups of factors of 2. So you can have 2 IPs only, 4 IPs, 8 IPs, 16, 32, 64, and so on. Everything has to do with the way that you do your subnet mask, which is just a series of ones, right? It's a series of ones that will define your subnet mask. VLSM is variable length subnet masking. It's a way to further broken the networks into different sizes. Remember that we don't have to have 2 pieces of 128 and 128. I can actually have 2 pieces of 64, 64, and a larger 128, or I can break that 64 into 2 32s, 32, 32, another 64, that makes 128, plus another 128 portion. So VLSM allows you to do multiple groups or multiple IPs, and like again, all based on the factor of 2 that so you can have all your space occupied, and then all of this is done by the subnet mask that makes it possible, because the routers will look at that subnet mask, and based on the network and the subnet mask, it will determine how many IPs or what range of IPs, 0 through 31 or 32 to 63, whichever ranges you have, of 0 to 127 and 128 to 254, and if it's split in 2 halves, where does it end and where does it start and where does it end? Now remember that on any subnetting or any range of IPs that you make, the first one is always your network number that cannot be used. Your last one is always the broadcast address. The broadcast address cannot be used either. It's reserved for broadcasting. And then as a convention, use the first available IP address for your host as your gateway. If it's a /24 where you have the whole 255, then 0 it will be your network ID, and then you use it .1 as your gateway. So it makes things a lot easier if you use the first one as your gateway. So how do these things all works? Well, you subnet your network and then make into groups and then become VLANs, right? VLANs, you have to assign a VLAN ID that goes from any number from 1 to 4094, with some exceptions that Cisco uses for the 4000 range. But they use 802.1q protocol. The 802.1q is a tag that gets added to the header to identify the traffic. VLAN 1 is a default VLAN, or sometimes the native VLAN, but it should not be used on a large network. Every time you see something that has a switch that has VLAN 1 on an enterprise network, please disable it. Don't use it. It's not recommended to use VLAN 1 because by default it's used for some systems, so you don't want to have that. Switches, like we said that before, that it can trunk or tag multiple ports, so you can have VLAN trunking and have multiple networks for sales, engineering, QA, finances, and all sent into your switch, and then some ports dedicated for finance, or so for QA, some for engineering, some for sales, the same thing on the other side. So in reality, this QA side here, virtually things that is connected directly to this, which they are, because it just layer 2 goes this way, it goes through the trunk to the switch, and it makes a connection to that QA. So they are virtually connected all together. If they need to go from one network to another, what do I have to do? Go to your gateway, right? Because it has to jump to a gate. The only way you can go from one VLAN to another VLAN is through a router and or your gateway, right? All of these switches, of course, they have to be managed switches, right? Managed switches, they do have a GUI or a CLI that supports the 802.1q protocols. If it is not managed, you can't configure anything. The unmanaged switches are just for mostly like home use and things like that. But for the most part, you want to do managed switches. How you can recognize a managed switch? Well, it will have a management port. Just by looking at the switch, you'll see that if it's a 24 port, you look around the switch, you will find a port labeled MGMT for management or console. That right there will tell you that it is a managed switch. You can connect through that and get the CLI access, the command line interface, or the GUI, the graphical user interface, to graphically see the switch, right? So each port can be configured, on a single VLAN to access, attack ports. That's an access port, or if you have multiple VLANs on it, it's called a trunk port, right? And again, unmanaged switches, the old ports are VLAN 1. It's like a fan out. There's nothing that you can configure there or get any information out of the switch, because it's just fully, it's a dumb switch. Now, switching gears a little bit, for network threats. Remember, network threats happens all the time, every time on your network. So you have to prevent hacking and be careful with those vulnerabilities that you have in your network and any exploits. Most of the time, through social engineering, phishing, or tailgating, human errors are the one that produce most of these incidents. So you can get attacks from DOS or DDoS or DRDoS. DDoS is denial of service, or a DDoS is distributed denial of service attacks, which they attack your network so much to a point that you cannot provide any services to your clients because it's busy doing other things. Some other ways to attack is through DNS or ARP poisoning, which is called the man in the middle. That when your DNS gets hijack and then provide different resolutions. You have to be aware of any virus, trojans, worms, or bots. Ransomware is a common one. But all of this, you'll see a virus usually propagates, it's like computer getting slow or crashing or something like that. With trojans, remember Trojan is like the Greek history. Is something that is disguised with something useful. So it might be a application that was a free, a small application you can download, but it has some software inside that it can actually take control of your computer. So those are the Trojans. So that's why you should have to do some partial safety and security audits constantly, some penetration testing, and do vulnerability scans, especially with the BYOD, like bring your own device. To do onboarding scans. If someone brings something from home, then it has to be checked to make sure that it's good for your network. You protect your areas, through a keypad, fob, or badges to make sure that no one gets in that is not authorized. Other ways to do is use the two-factor authentication or MFA. There's a multi-factor authentication that then you require more than one way to identify yourself into the network. Most important also, create an acceptance user policy. It's important to make sure that users know what are they supposed to do, and sometimes a non-disclosure agreement to make sure that when they leave or when they go home or they work with other people, they're not going to disclose information from your business. If anything happens to your network, there's a time for recovery. The recovery is that process to repair the affected systems, right? That's how you recover from a system. That's the time to do that. Now, when something happens, any of these incidents, the most important thing to do here is that who, when, and how. Who has to get notified? When did this happen? How did it happen? And then it has to be find a remedy. And a solution, patch it, fix a vulnerability or any exploits, and fix the problems. So how can I protect myself from these vulnerabilities? Well, the use of firewalls, right? And IPS or IDS, the intrusion prevention systems, intrusion detection systems, or sometimes even proxy servers. The next generation firewalls work all the way to layer 7, so you can actually go to what's called application control and then control the applications there. Routers can protect you up to layer 4. The access list can only do layer 3, layer 4 comments on it, right? But both the firewall and the routers applies rules in sequential order, right? They'll go like in sequence. You have to be careful how you apply those those rules and make sure that the more granular gets hit first, and then the more broad gets hit later, right? Also, those ACLs on the router should be applied close to the device being protected. The same thing we have a firewall. Firewalls, if you have one firewall for your system, it should be applied at the aggregation point, which is more like at your edge, right, at the edge of your network. If both of this can inspect traffic based on source and IP addresses, so an ICL, you'll see an ICL says access list allowed TCP from source IP to destination IP and the port number. So you can actually build an ACL, or on the firewall, a rule that says, inspect the traffic from this source to this destination, and build a rule like that. You can also have host-based firewalls to protect the systems, right? Windows comes with a host-based firewall. Most of the time is enabled and allows you to protect to some things. You can also have a SIEM, a security information and event management. This is just to monitor, analyze all the logs, right? It correlates events. That's the one that can aggregate multiple things and say, hey, I see Active Directory, I see your radio server, I see your router's connection, I see the firewall logs, and then correlate all that and see what are the users doing on your network, right? Be aware of the zero-day exploits, right? This is when a hacker releases a malware, an exploit, or vulnerability, over a vulnerability before the developer has patched the flaw. So some software, they do have vulnerabilities that the developers don't know yet. That's why they haven't patched it yet. So the zero-day exploits, when these hackers look for those things, finds them, and it starts to exploit them before the developer can provide a patch for you. Now, there are other ways to secure your network. I mean, you can have what is called the CIA triad: confidentiality, integrity, and availability, right? So different methods of things that you can use. The AAA, remember the AAA is for authentication. So you have to authenticate yourself to who you are with your password or your single sign-on or multi-factor authentication to see who you are. Then the system will provide you with authorization to see what access you have based on your credentials. And then accounting, which is just the login of everything that you do, when you came in, how long you stay, where did you go, and all that. So that's part of the AAA. Now, radios, it's authentication mostly for wireless and remote access, right? It's widely used on wireless. But also VPNs for remote access will use radios. And what they do, they authenticate against Active Directory, which Active Directory, remember, is the Windows centralized directory that it keeps all your accounts, all the users and user profiles, and they can actually determine to see what access you have and relay that information to a radio server and provide that part of the authorization when you get allowed into the network. One of the good security feature they can have is also the Kerberos. Kerberos, it works on Windows and also on the Mac systems, but it's a secure authentication services for user and applications. This is where you can access resources or files, any sharing that you can do. You can also get authenticated and everything handled with the ticketing system. Remember, with the ticketing system for the Kerberos. Network segmentation is another way, using VLANs. Remember, if you have a management VLAN that's isolated, that way I protect my management network. If my cameras doesn't need to be seen by anybody else, I can put a separate VLAN. The voice gets on a separate VLAN. So network segmentation with VLANs is a way to secure your network. Honeypots are decoys to attract and deflect hackers. This is kind of like a candy that you put there to an attacker. Say, hey, I have a system here, and then that way you can see what are they trying to do, how they're attacking your network, and what is it that they're looking for, and even where they're coming from. So honeypots are really, really useful when it comes to the networks, and it's just kind of like playing with the hackers. You should have also the PKI, that's the private key infrastructure. That's the cryptographic key pair that you use to secure your websites and some communication, even for your wireless, you can use a certificate, from PKI to encrypt your traffic, and it's all, obtained and shared through a trusted certificate authority that authenticates validates your certificate. Again, penetration testing, I mentioned that before. It shows something that it should be done on a regular basis, and they use MFA, SSO, or biometrics. And biometrics is a way to physically test you, either through your a handprint, fingerprint, or your retina display, retina scan, so so to see who you are, right? And one of the things in security that people completely forgets about is NTP, the network time protocol. Network time protocol. If you're not in sync, your application might not authorize or work together. It uses UDP 123, right? NTP. It's a small service, a small protocol, but it saves you so much trouble. Case in point, we have, if you happen to have a Peloton device, either a machine or a treadmill, the bicycle or the treadmill, those machines have a hard time getting NTP. If they don't get the correct time, they will not connect to the Peloton service, because it needs to be at a specific time. It has to be at least drifted a couple minutes, but not days or hours or months or years. So NTP is important also in security. Make sure that you have all that down pat, for your clock syncing on your network between devices. Spanning tree protocol is another protocol that you should spend some time to try to learn it, because if you have multiple switches, you'll see that if they interconnect to each other to provide redundancy, they create a loop, right? And these layer 2 network loops is when the frames start going around your network, and it happens so few milliseconds that in a few seconds your net will be brought down to its knees, at least at the layer 2 level, right? These VPDUs are sent out between switches, and that's how they choose who is the root and who are the designated ports and who's going to route the traffic. So they have a spanning tree priorities for a device, and that's how they build a tree based on that root, where the root will be the top of the, in this case, the root bridge is the one on top, and then they will decide which link to break. Right, so the looping are usually disabled on one end. It's not both ends gets disabled, only on one end. And if they're required again, then they'll be re-enabled in case that the topology changes and they're needed again. This port will be re-enabled. Okay, this is something that also you spend some more time, spend more, because beyond the network plus, you're required to learn more about a spanning tree, because I have seen many times people looping the network, not knowing that when you even connect a port to a port on a switch, you create a loop there, and the spanning tree needs to be configured correctly in order to avoid those loops. But like I said, mostly human errors is what creates a loop. SNMP, the Simple Network Management Protocol, is something that I wish we could have months on this, because they provide visibility of your network, right? You got SNMP v1, which was original. I have replaced with v2 that has a little bit more robust passwords. But then v3 came in that actually makes it more secure, and it's encrypted. So if you want to run SNMP, make sure you run SNMP v3 if supported by the devices. They use what's called a MIP, Management Information Base. That is a tree structure database with multiple values for the location of those values, and then data is stored on those values. So like uptime, IP address, location, input-output traffic, errors, anything you can get there. So to get full advantage of SNMP, you need an NMS, a network monitor system, that would actually retrieve these values from the MIP and then start creating baselines. Remember that baseline is important on your network for troubleshooting. If you know how your network runs on a normal day, then you will know what happens when something is not working right. Because how do you know? How do you distinguish what's right and what's wrong if you don't have a baseline? So one of the first things you should do as a network technician is to baseline your network and see how much traffic you generate normally within your traffic, and how does it look for different locations. So all managed devices supports SNMP. Unmanaged devices, of course, don't support that. the manufacturer usually provides their own MIP, which has extra fields for information for that particular device. And again, unmanaged devices do not support SNMP because they're not managed. They don't have an IP. They don't have any way to get into it to retrieve any kind of information. So they don't even bother to build SNMP. Now, some of the cheap switches that sometimes they say that they do have SNMP, you can get very basic information, but you cannot get like as much information as an enterprise a great switch that it can give you all kinds of information on the ports and the switches, statistics, temperature, load, and all kinds of things like that. So unmanaged do not support SNMP. And I want to cover this really quick. It's not included in the book, but it's RAID. RAID is a redundant array of independent disks, and it's used for storage. So there are a few basic RAIDs that you should know. The RAID 0 is when you have two drives, right? And the data is split between the two drives. So you start writing into one drive and another drive, and you start writing across the drives. It's a lot faster because now you're writing at twice the speed, right? Because you're writing to the two drives at the same time. So RAID 0 provides that. So it increases performance, but it's not fault tolerant. If you lose one drive, there goes all your data, right? So they have what's called RAID 1. RAID 1 makes a mirror between two drives. So RAID 1, it will write data into one drive and it will copy the same data into the second drive. This way, you can lose one drive and you have a completely duplicate on the second drive. So you can literally, as a hot swappable, you can remove drive 0, replace it with a good drive, and then the RAID will rebuild the drive. So within a couple hours, you have your data completely mirrored between the two. Again, it's a duplicate for fault tolerance. But for this one, you have to kind of like waste a drive, right? You have to have two drives sitting there. So they created RAID 5. The RAID 5, you need 3 or more because it uses what's called a parity. And the parity, it will write data into one drive and the other and the other. And then see on the last one, it creates a parity. That the parity it's used to rebuild any of those drives. So if drive 0 fails, the parity and information between drive 1 and 2 can rebuild that drive. And then if you see along here that the parity keeps moving, so the parity goes into the different drives. But drive 5 is fast because you're writing to multiple drives at the same time, right? And it is fault tolerant because if anything fails, you pull one drive and replace it and it gets rebuilt. Now, RAID 5, only one drive can fail, right? When you replace it, it will get rebuilt, but only one drive can fail. Now, the RAID 6 is an extension of the RAID 5, which you need a minimum of 4 drives. But this one uses 2 priorities. So it's a faster read, it's a slow write, but it's a fault tolerant. So in this case, you can actually lose one drive and you can lose 2 drives, and this can still recover the information. That's something quick to keep in mind when you actually hear something about RAID. This is used for storage systems or servers with multiple drives that you want to make sure that data is never lost or corrupted. Just a quick review on UPSs. UPSs, remember, is the uninterrupted power supplies. This provides a battery backup in case that you lose your power system. So it also provides protection against surges, noise, burnouts or blackouts, something that can damage your equipment. So some of the online UPSs can provide what's called line conditioning. So it makes the power cleaner, right? The battery has what's called a runtime. The running time is calculated based on the battery capacity and the load of the UPS. How long can these batteries hold this load, right? So they're not meant to run the equipment until the batteries are exhausted. If they do, you will damage the batteries. Running too low, it will damage the batteries. Some people have at home little UPSs that when the power goes out, they let it run until they die. Well, no, they're meant to shut down your files, save everything, close your computer, turn it off, and then turn off the UPS. Don't let the battery drain because it's not meant to do that. Heat can also damage the battery. So if they're meant to work for 3 or 4 years, if they are in a hot environment, like in a garage or something like that, or in a closet that is too hot with no air conditioning, those batteries will last like 1 or 2 years rather than 3 or 4. Some of these batteries are what's called SLA, the sealed lead acid. Yeah, they run for 4 to 5 years if they're treated well, they're not drained too low, or if they're not in a too hot place. So there's online UPS. Usually the power comes in and it feeds the service, and it goes into AC to DC to charge the batteries, and also it goes straight into your load. So that's an online UPS. At the moment that so the power is always coming from the batteries, so it's always charging the batteries. You have the other system with the standby UPSs. There's some UPSs on the normal running operation, it runs through the AC power and it just goes from the outlet straight into your load. The moment that you lose power, then the battery starts to kick in, and it provides through a inverter to provide power to the load. Now the switching here is so fast that your system will not see it. But this is a standby UPS. This is an online UPS where it's always online. This is for large enterprise. This is where you have normally an online UPS. If you are a good network engineer or network technician, you will have a disaster recovery plan. Any enterprise should have a disaster recovery plan, including documentation for diagrams, instruction on how to restore or replace equipment, any agreements they have to provide is for fast recovery, like if something gets damaged, how can I get new equipment replaced? So for that, you can have a cold site, which is not ready, not configured, not connected, and has to do all the work to get it up and running, get all the backups and restore them. You can have a warm site, which is somehow configured. It is connected, it's nearly ready, but it still requires some manual input for you to do it. Or you can have a hot site, which is all configured, connected, and ready to go. It's like a mirror site, and sometimes the hot sites are active standby, so your equipment is active in one location and standby at another on the hot site, and the hot site, when it needs to, it will come online and provide services immediately, right? Sometimes, like I said, even automatically. So to have redundancy in your site, you need multiple sites with internet access, right? Activate data links to multiple sites. Have other ways to connect back to the network. So if you have this computer connecting to this switch access, it goes to a router and it goes out to these servers, then if something happens, it can always go to the other core and still reach the server. If that server is not available, then it will go to the server and it will always be up and running. So that's, you have two servers, at least two core routers on the access layer, so you got only one switch, but the switch has multiple uplinks, so you have redundancy on that, and the computer gets connected there. So, and these are the multiple uplinks, so you can get redundancy there. So the dual configure equipment is able to handle the load. Link aggregation can also provide safe healing networks. Link aggregation means that the two ports are active at the same time, so you provide better performance, and at the same time, when something fails, the one half can keep on holding that. Load balancing also provides some fault tolerance, that's especially on the server side. So if you have servers with a load balancing, it will provide, even though they are connected for disaster recovery, this equipment is there, so it can still be used to provide some services. Just remember that at any moment that one of them fail, then you should be able to get the one server that stays up to handle all the traffic from the whole enterprise. Now, if you want to do a quick refresh on Network Plus, just before taking examination, something like that, I would recommend this Exam Cramp Network Plus. The N10-008 is the latest. You can get that from Amazon, from any other places. The Kindle version, I think you have also the electronic version, that you can rent the electronic version, which is a little bit cheaper. Or find it from somebody that has it. But it is a good book. It has a lot of pointers, a lot of condensed information down to the point of what you need. So if you know your OSI and your SNMP and your VLANs and all that, if you're familiar with all those terms and you feel comfortable with that, then use this book. This book will give you a little bit more insight on get you prepared with some of the important details for the examination. And that's it. That's all, folks. The video, I try to keep it under 1.5 hours, and I think I did. It's like about an hour and 20 minutes. So not much, but a little bit. Go back and review things that you need to. Like I said, this is something that I will see on I will ask someone on an interview. So they're welcome to review it, save it if you can. I'm going to put it on YouTube to make it available there. But if you have it from your Blackboard session, then you can probably save it in case you want to review it again on some later time, or keep it as a future reference. Okay, thank you very much, and thank you for the past hour, 20 minutes of staying with me. Bye.